Continue the session, and now we will move on to the next stage, that is PI controller, and then we go with FLC also. Okay, so before going into that, this is our converter. We have obtained the level of the converter and we get the output. But if I want to connect to the inverter, or I want to set the particular voltage, so for that we have to go with one inverter block, as well as we need one controller loop. So for that we go with the PI controller. So again we take the same circuit for our reference. Okay, and one more thing, actually most of them have technique of this. I will tell you, just note down this, but here it's not a frequency domain, so it won't work. Okay, actually I have to click this input line. Just click this input line and you have a right click option and you have a linear analysis point is there. Okay, anytime for any frequency domain analysis, we need not to worry about that what is the input, what is the output and all. Just click the input line, in the right click you have a linear analysis point. In the linear analysis I have a input perturbation. Okay, I may take it, and in that output line I click it and I have a linear analysis point. This is open loop output, okay, or output measurement. I can choose this. Then I have to run the program. Okay, after run the program I have to go for the analysis, and in the analysis I have a control design tool, and in the control design again I will choose the linear analysis point. And if I choose the linear analysis point, I may see the various results. Actually it is not in a frequency domain. I get my step response. Okay, in frequency domain I will get it the result. So there is way, so you can see to that new Bode, new impulse, Nyquist plot, pole zero map, so all these things we will get it. So once again I will repeat it, how to get this and all. It's not a okay, you have to get the right click on this input line where you are going to get it in the scope. Take that input point and right click on that. You have a linear analysis point, and in the linear analysis point you choose the input perturbation, and then similarly in the right click again output, choose the linear analysis point, output open loop output. Then you run the program. After run the program, go to analysis. There you have option of linear analysis, and in the linear analysis you may get all the curves. Okay, so this is another way of checking the linear analysis tool. In the any converter we can do that. Okay, so now we go with the next one. So this you can use it for your pole zero plot and all. Actually this is we are going to solve PI converter. Linear analysis, sir. Actually in the linear analysis point, click on the input, right click on that, you have option of linear analysis point, and then you can choose this input perturbation. You can see that open loop input, open loop output, loop break and all that. So here it's a input perturbation, and in this output again you right click on that, again choose the linear analysis, right click on that, choose the linear analysis point and choose the open loop output. Then you run the program. After run the program you have an option of analysis, and in the analysis we have a control design option, and in the control design we have a linear analysis where it will take to another window, and here you can get all your plots. Okay, it is mainly in the frequency domain analysis.
After choosing the plot type we have to again linearize.
No, it will come automatically. If new step or else new step, Bode, actually it is while we are doing in frequency domain it will work properly, but here we are all connecting the DC source and all. Here for this particular converter we are not getting, that's why we have gone through this procedure, but when we do in the frequency domain it will work properly. Okay, if you go give with feedback converter, PI, FLC and all, you may get it. So this is one of the way to get all this. And the next one is, I'll go with PI converter. Okay, so first you try to give the we try to connect with the output waveform. Okay, so I think we may connect the DC source, I may connect the DC source here, and in this DC source okay, we are connecting one inverter part. I think this inverter arrangement, how we are connecting, we are normally 1, 3, 5, 2, 4, 6 and all. So I think 2, 4, 6, 5 6 will be there, yeah, 6. Okay, and while we are giving the pulse, it's 50 Hertz frequency we will try to give. So 1 by 20 millisecond, and pulse width we will give 50%. And if I want to do the conversion for the next, it is 60 degree we will give. So while you giving to the conversion, if I give it like this, actually we are connecting the Kai-Boost converter to the inverter setup, and from the inverter we take the waveform, 3-phase waveform. And yesterday sir thought about the multi-level inverter. Again when I go with that multi-level inverter inside the inverter box, automatically my THD value will be reduced. But while going with this type, we get THD around some, because we get only stepped waveform. So around 70%, 80% will be there. But when you go with my multi-level inverter, you may always obviously get it. So here how we are going to give that pulse, this is the way we are going. I am put it in a thing. So period, because 1 by 50 Hertz, it's nothing but 20 millisecond is there. Okay, and pulse width I gave 50%, and phase delay for first switch my phase delay is 0 degree. Phase delay is 0 degree. But if I do the phase delay calculation for other switches like 2, 3, 4, 5, 6, how the phase delay is calculated now? Totally for 360 degree, it is 50 millisecond, 20 millisecond now. Actually I have to calculate for 60 degree. This will turn on at 60 degree, and this will turn on actually 60 degree, 120 degree, and 180 degree, and 240 degree, and 300 degree. So how I will calculate my phase delay for this one now? For the second switch, I will calculate my this 360 degree, it is 20 millisecond now. I have to calculate for 60 degree, what will be the value? So 60 into 20 millisecond divided by 360 degree. So when I calculate, my value is almost 3.33 millisecond. Okay, this is the way I have connected for the second switch, and for third switch, and fourth, fifth, sixth. So this is normal inverter, it's not a multi-level inverter. Yesterday we have seen with the multi-level inverter what S1, S2, S3, S4, S5 switches, and we connected that. But one more thing, how to build this block, that is we have to choose this, in this we have to go for the model or subsystem. When you search subsystem, okay, you may take it the subsystem, and in the subsystem you may want how many inputs. Actually in this subsystem I need 2 inputs and 3 output is there. So when I go with that, again I have to give this connection entirely. Okay, and in between that I have to connect all these elements. All the 3 switches I have to connect, and then connector 1, connector 2, connector 3. So this is my inverter setup. So inverter setup, while I am seeing here, my phase delay is 0 degree, and I will move on to my second switch. My phase delay is 3.3 millisecond, and then I go with my third switch. My phase delay is 6.66 millisecond. Actually every millisecond it will add with 3.3. Okay, and when I go with my fourth switch, it is around 9.9 millisecond, and when I go with my fifth switch, my value is 13.33 millisecond, and when I go with my sixth switch, my time delay is 16.66 millisecond. So this is the way I will just put my phase delay, and I have 3 outputs, and 3 outputs I have 3 phase measurements. So in the 3 phase measurements, I have to choose the signal label VABC, IABC like this. After choosing this, I will get a label. So if I run this program, actually, once again, this is not I have connected, show. This is for multi-level. Okay, so I think I have given for the multi-level. We go for the single level. Multi-level we will see in the afternoon session. Here I may remove all this data sync and all. Why we used now? Because to connect our, to see our transfer function only we have connected. So here I have been seen with this. So I may connect with this. I can connect my output here. VABC, IABC is been there. Similarly, IABC is also been there. This is nothing but a to label I have used. Here itself I have to mention VABC1, IABC1. So 3 phase we have to connect it in terms of my DMUX I have used to get a waveform separately. So now again, once again I run my program. So in the simulation, always use the model parameters. Stiff model, you just use it. It will run in fast. Okay.
Ma'am, the killer field minus connect. V not scope 6.
Scope. Okay. Okay. So I will get this waveform for my output, and here I will get my 3 phase waveform. And this is for voltage, and current I have kept my resistance value as around 50 ohm. So around it was being the value will be there. So here when I see my THD value, it will be comparatively higher only. So if I go and view my THD value, and again to view the THD, you go in the discrete and you have a FFT analysis. FFT analysis, you click on that and see to that here we have to save our data. So go to settings, history, TR out 1. Okay, we will just choose it. So in the FFT analysis, we will choose TR out 1. Okay, so here we may put the time period from 0.2 and we take number of cycles and maximum that frequency we will choose 5 kilohertz and we will display the value. So THT is around 30.15. So we can give the justification that THT value is 30.15 and we go with multi-level converter also. So here the Kai-Boost converter is connected to one inverter setup along with the load and we have seen the output waveform. Now we are going to use the PI controller for this circuit. So we will take the block of PI controller. Here we have only 2 pulses. So we kept the voltage as a 325. So I think yesterday sir gave how to choose the PI values. I think it will be very useful while you are doing your calculations. So this Kp, Ki is very, very important. We are simply saying that it is being used with Ziegler-Nichols method. But when you choose this PI value, that is my Kp, Ki, Kd value for while I am writing for my PI controller, this is 0.9 T by L and L by 0.3. Actually, how we are been choosing now, while I am getting my value, it after the some oscillation only it will get settled. So I have to find out this time period. And from the time period, I have to design my proportional gain, integral gain and all. And here when I find out this is my rise time and I have to find out my fall time and I have to find out my settling time. And then finally it is settled to some value. For example, it is settled, we are kept as a 320 volt and it is settled to some 320 volt. That steady state error is 1 volt. So all this we may obtain from our closed loop condition. Open loop condition, how we are been ensuring the values we will get now. In the closed loop condition, find out the waveform, output waveform, and from the waveform find out my Kp value and Ka value using these formulas, and then you may try to find out the values and then try to settle out there. But you may compare with, normally when you go with a converter, which is the best controller, there are so many optimization techniques are there, but when you choose which is the best controller, PI controller, and apart from the PI controller we may say to that fuzzy logic controller. These two are the very best controller, and using this two controller we may design and we may reduce the values also. Okay, so I have taken my here and I will expand my subsystem. Expand my subsystem, and here also you expand it and you try to give this and okay, so you remove this pulse generator, and you try to give it in this block. Expand system. So here again okay. You connect the repeating sequence. Repeating sequence always actually it are been that 2.5 millisecond, 5 millisecond, 7.5, 10 millisecond, and this is my time value, and corresponding my input and value with the positive and negative. I am comparing with my relational operator greater than or equal to, and again I am feeding with the logic of pulse generator I am giving. So while I am giving one with phase delay of 0 and another with I may give the phase delay 1 e power minus 4. Same thing what I gave there. So here when I run this, again if I want to expand, I will give expand. I think while I am giving expand, the waveform, I think the monitor resolution is somewhat less. Okay. So if I run this program, so you can see to that this is my peak value and it will be varying. So we have to reduce this final settlement value. So first you just connect this inverter setup. After connecting the inverter setup, you try to give the PI controller along with this waveform. Before entering into that, I will explain you how to do the fuzzy logic controller. Okay. Circuit disturbance. Open. Downloads la MATLAB la. I'll tell you how to write the rules, and from the rules how to obtain the values. So here I'll connect the DC source. Connect the DC source, and here how to write the fuzzy rule. I will explain you how to write the fuzzy rule. Before going for the fuzzy rule, first you have to Just follow this procedure. It will be helpful for you to write fuzzy rules and all. So just type fuzzy. In that fuzzy, you will get automatically one window. Okay, here only you are going to write. Before going into the side, I will show you. See, okay. See, just see. So here I will get my reference voltage and this is my actual voltage. I will compare both the voltage. So I will get error and change in error. And change in error I use du by dt with respect to time, or I use my memory element. So error, change in error is fed to FLC controller. FLC controller will produce the duty cycle and that particular duty cycle will be given to the multi-input KY boost converter. So here I have a we can see to that error negative big, negative small, 0, positive small, positive big is there, and similarly here the values, so that we are going to error and change in error. This is my output of the FLC. This rules we are going to write in the fuzzy block. Okay, not only 5. When I go with that, I can give for 7. 7 na, we see to that 5 na 25 rules I will get it. 7 na 49 rules I will get it. 9 variables na 81 rules I have to form. So depending on the this particular negative big, negative small, 5 cross 5 or 7 cross 7 or 9 cross 9, what. So now we will write basically two things. How we have to write for PI controller, we have seen that just give the proportional gain and integral gain and give to the repeated sequence fed to the phase chi boost converter. But this is the advancement of the FLC. Why we are going for FLC and all na? The results always means to that, you see to that my PI and FLC, normally when I go with my PI controller and fuzzy logic controller, the value will be somewhat reduced in the FLC controller. So FLC is a topmost converter and you get the value. Okay, now I will tell you how to get this right in the fuzzy logic block. So for that, you just type fuzzy. You just type fuzzy. You just follow the same steps along with me. Fuzzy, you type it, and once you type fuzzy, the fuzzy block will get open. The fuzzy block will get open. Okay, but I need 2 inputs. What are the 2 inputs I need? One is error and another one is change in error. What is my output? Output should be in the duty cycle format. So input is error and change in error, output is duty cycle. So first what I have to do, file. Okay, and you have to add variable. I have to add input. So I have got 2 inputs and 1 output. So what is my first input now? I have to give the name error. I have to give the name error. And what is my input 2 now? I have to give the name change in error. I have to give change in error. So I gave 2 inputs, error and change in error. And this is my output. Output I have to give, what is the name? Duty cycle. Duty cycle. So I got my input and output. Okay. So this you have all entered. After entering, what I have to do, I have to create the membership functions. So our aim is 5 membership functions I have to add. So first what I have to do, first I select this and membership functions, I have to delete all the membership functions. Okay, so what I will do, remove selected membership functions. Remove all MFF. So all my membership function get closed for first one. Similarly, when I go with my second, I have to remove all MFFs. Okay, and this is over. Then duty cycle also, I have to remove all my membership functions. Okay, so I have removed all membership functions because now we are going to construct a new thing. So first what I have to do, I have to give the name. What are the thing I have to give now? This is I have to give. This is my membership board. So I have to take this as a reference. Okay. So you just see. What are the thing I have to add? So I have to add my membership functions. For input 1 I have to add. So add MFFs. Add MF. If I add, how many membership function I need? So I told you maximum how many I can give? 9. So 9 into 9 are 81 rules. Normally the people will give 7 into 7 49 or 5. Now here we are going to give 5 only. So just select 5 and give OK. So 5 membership functions I will add. So while I am adding, I have to give a negative big I have to add my membership functions. Negative big and MF2 is what? Negative small. Okay. And MF3 is 0. Then MF4 is positive small. Positive small. And membership function 5 is positive big. I have to give like this. So I will get 5 membership function for this. Similarly for change in error, I have to add the MF. So totally here you can see that MF type, normally we have so many rules, triangular, trapezoidal membership function, but we are choosing the triangular. So 5, okay. So I can able to enter 5. Okay, so change in error also I have to enter 5. So what are they? Negative big, negative small, negative small, then MF3 is 0 and MF4 is positive small, MF5 is positive big. Okay, close. And then you go with the duty cycle. Here also I have to add the membership function. So here I am adding membership functions. So give add MF and how many variables? 5 variables are there. So I am choosing 5 and again I giving OK and 5 membership function I have to add. So again same thing. Negative big, negative small, then 0, then positive small, then positive big. Okay, close. So I gave 5 membership function. Now I have to write the rule. This is my table, I have to form a rule. I have to form a rule from this table. Okay, I am going to write the rules. So view, rules, edit rules is there. I have to write my rule. So totally I have 25 rules I have to form. So error is negative big. Change in error is negative big na, my value is positive big. Add rule. Okay, then here AND OR connection is there. I have written only the AND variable, not OR. So connection you can choose AND, OR and all. Not is also there. Okay, and the next one is negative big. First I have to complete this row. Negative big na, positive big. Negative big, negative small na, I have to again choose positive big. Again add the second rule. Then negative big 0 abdina, I have to use positive small, add rule. Okay, negative big positive small na, add positive small, add rule. Negative big positive big na, what is the value? 0, add rule. Okay, and then next I am going with the negative small. So negative small, positive big, sorry, negative small, negative big na, my value is positive big, add rule. negative small with negative small na, I'm just mapping this. Positive small, add rule. Okay, negative small with 0 abdina, positive small, add the rule. Negative small with positive small na, again negative small, add rule. Negative small with positive big na, negative small, add rule. Okay, then again I will go with the 0. 0 with negative big na, positive small. So similarly I have to add all the variables. By seeing this tabular only I am adding. Okay, sorry. 0 with negative big I forgot to write. 0 with negative big na, what I have to write? Positive small, add rule. 0 with negative small na, positive small. Okay, correct, I have written. Then 0 with 0 na, again I will get 0 only, add rule. 0 with positive small, negative small, add rule. 0 with positive big na, negative small, add rule. So 15, we have completed 3 rows. Now we are going to the 4th row. It will be positive small, add rule, with a negative positive small with negative small na, it is again 0, add rule. Positive small with zero na, negative small, add rule. Positive small with positive small na, negative small, add rule. Positive small with positive big na, negative big, add rule. So 20 rules we have formed. Almost the last one, last row we are been doing. Add rule. Add rule. Negative small, add rule. Positive big with positive small, negative big, add rule. Positive big with positive big, negative big. So totally we formed 25 rules. Okay, after forming this 25 rules, you just close it. After closing it, actually we have to download the FIS file. While running our software, we always require the FIS file. So file, export to file. So automatically you can get it untitled. So I may download it in any other place. Okay, so I can give it as a F1. I may give it the name F1. Then if I give save, so automatically what happened? The file name will be Mamta. Actually here we have a 2 membership function. One is Mamtani, another one is Sugno. So here we have developed using Mamtani. So F1 will be there. Once F1 is there, we have downloaded it. So while we are running our fuzzy, we have to go to this, and here I have to give the name as a F1. Okay, here I have to give the name as a F1. So apply, okay. So the file is automatically loaded here. Not only enough, then again I have to go to this window, and here I have already fuzzy is there, this will be there. I have to export that variable. So export to workspace. So if I export to workspace, you can see that my F1 will be loaded in the workspace. So once it is loaded in the workspace, then again when I am running my program, automatically the file will comes here. Okay, so one KY boost converter we have taken, and we have analyzed how to get the transfer function, and then we have seen how with the PI controller and all. Then we have seen the rule, how to form the rule in the FLC, and we can go with the FLC, and we can conclude that with the rise time and all. So you may choose any of the converter in a way. We can use it in various applications. Not only in inverter, you can connect it with the any other applications like BLDC motor you want to connect, you can connect with the BLDC motor, or depending water pump applications are there. So that you have to connect. So anyway, you want to get a closer waveform, yesterday multi-level converter also helps you to do that. Okay, and you want to connect with any shunt filter arrangement. First day sir have explained the shunt filter arrangement with the reduced THD. We have connected the switch and we have done that. So the way you may get it, and finally it will be tuned to our waveform. Okay. So I think the morning session, afternoon session, we will see that how we can use the multi-input KY boost converter. Now in the same setup, you connect one inverter arrangement and then you connect one PI controller and see the output, and then you connect the FLC controller and you can see the output. Okay, sir, thank you.